So this is going to be a little bit of a review because we're going back to script tools, which hopefully that'll be timely because you're needing to use script tools now for your project. So the tool validation, there's an internal validation which is built in to any tool that you use, which is filtering things for you. And you can add your own tool validation with the ToolValidator class, which is one of the tabs that you may have noticed when you created your script tool. The tool validator allows you to create a much more interesting and dynamic script tool. For example, suppose you want to allow the user to browse to a land cover file and then pick the field that represents the land cover. Well, the field name can be populated dynamically using the obtain from parameter property, so that the second box there can be dynamically populated with the fields that are in the data that the user selects automatically by using just that obtain from property. But then suppose you want to get all of the land cover types that are in that data in that field and the values that it has, and then allow the user to pick one of those values to do an operation on. The built-in parameters don't allow you to do that, but you can do it pretty easily with the tool validator by setting that parameter so that there's some code behind it, that when the user picks out that input file and then that field name, that the values can be found in the data. So this is one cool way we can use the tool validator, and we'll go into detail with an in-class example that implements this. But first we've got to get into the nuts and bolts of how the tool validator works. There's internal validation, which has built-in checks. Say, for example, if you try to point to a data set that doesn't exist or isn't supported, like if you write ctempbogus.py and it's supposed to be a feature class, so if you've set it up, if the parameter data type in the data type column is feature class, and then when you run the tool, you try to use a Python script, it's going to automatically give you an error. Okay, that's part of the internal validation, what's built in to the script tool for the way it works. And it also will do things like check to make sure that you've entered. When you click OK, if you leave some of the required parameters blank, it will find that out and give you an error message, and it won't try to run the tool with the required parameters empty. So those are some of the internal validations that are built in. But you can add additional ones, and you can put code that'll do things that'll say, you know, update another field based on what one field has. Or check something more sophisticated than whether it's, you know, ends in SHP or exists or not. So that's what the tool validator class is there for. When we talk about class, it's exactly the same thing as we were talking about a couple weeks ago when we said user-defined classes, right? The keyword class and a name, which is in this case tool validator, and then it has, remember this, the function definition with the init, right, with the underscores on either side, just like we've talked about, and then self. And then it has three other methods inside here, the initialize parameters, the update parameters, and the update messages. And all of those, by default, just have self as a parameter and have a return statement that doesn't do anything, returns nothing. And by default, this has import argpy, and it has another statement that we'll look at in more detail in a minute. It's an assignment statement for parameters. So to get to this tool validator class, you go on your script tool that you've created, right-click, and you get properties, and that fourth tab there is the validation tab, which we've up till now been entirely ignoring, right? We've stepped through, done the general, the source. The source is, what does the source do? Remember what that tab does? That's where it points to the script that you want to run. And the parameters tab is the tab with the 2 columns, right, that has the names of the parameters and then the data types of the parameters. So this is the next tab over. And so what kinds of things can you do with it? You can do things like enable or disable a parameter. So say if you have a, I've got to think of a good example for this. Off the top of my head, I'm not good at that. Let's just read what's on the slide. Okay, so if you have something such that you want to say, if the user selects a point feature class in the first parameter, display green eggs and ham in the second parameter, but if the user selects polygon feature class, display spam and alter spam in the second parameter, these are references to Monty Python, then you can do that with the tool, the enable and disable. You can update a parameter filter. You can do things like get the file that the person has selected and do a list field names and get those field names, get some information from those field names and update another so that the user can pick from something in the list. You can also create extra warnings. You can use categories. You know how some of the tools in ArcGIS, you pop them up, they have categories of information. And you can also update output data descriptions. That's really to do with Model Builder. Probably won't go over that. Remember the tab where you set the parameters, you have the display name and the data type. And if you look at those parameters in this table, from top to bottom, we'll number those 0, 1, 2, 3, 4, 5. And that's just how we reference them in a script, and it's also how we will reference them in ToolValidator. So I said we'd come back to this line in the init that says get parameter info. Well, that is getting the parameter info from the parameters that you've listed over here, setting up these parameter objects. So the ToolValidator class has a property which is a list of parameter objects. Self.params is a ToolValidator class attribute, which is a list of parameter objects. As I mentioned before, there are 4 methods inside of the ToolValidator. The init method is there to initialize the ToolValidator class and perform any imports and initialize the object properties. Right now, it's just doing self.params. The initialize parameters method is called once when the dialog box first opens. The update parameters is called every time a user changes the parameters. So this is one that you want to use if you want to do some dynamic behavior with the parameters. So that updates every time a user changes a parameter. The update messages is called after the user updates any of the parameters or clicks OK. So that's at the same time, you know, when you click on a tool's OK button and you haven't put in all of the required elements or one of your elements is wrong, that's the internal validation going on. So the OK button, or after you click in another box to change a different parameter than what you were just working on. I kept talking about these parameter objects, and they have a set of properties which include the ones that are listed here. There's a link on our in-class exercise to the properties. I'll point out a couple in particular. Altered is Boolean. That means what values can it have? True and false, right. So it can have true and false, and it's set to true if the user has modified the value since the last time it was checked. So you can use this if you're wanting to check on something having been changed, altered. Enabled, if you want to make a parameter unavailable, say you want to turn off an option when the user picks some other thing. You can set something to enabled. Say they don't get the chance to choose what type of, or what field name if they're not choosing a input data set, if they're going to use something that doesn't pass that in. It has a name. Let's see, what else? Altered, enabled. All of these, so it has a value, right, which the value of the parameter by default is whatever the default value is set in there, or if you don't set a default value, whatever the default value that ArcGIS sets up. For a lot of parameters, it's an empty string. Okay. But when the user enters a value and moves to a different box, then that gets altered and the value gets updated. So it's listening to what the user is doing, so it gets updated once the user sort of commits that by moving to a different box or clicking OK. This is just the default that the init has. If we want to, say, set up a filter in our code, like we want to get something dynamically, maybe you're reading a CSV and you have to fix the CSV up before it can be read. You could do that right inside of your tool validator and then set a filter that'll list the field names, for example. Here the list is hard-coded, but this statement is being self.params1, which is in your table, it'll be which one? Counting down from the top, starting at 0. So it'll be the second one. So this is setting the second parameter. So the second parameter also on the GUI from the top, the filter for that to a list. So that'll give you a drop-down box when you look at it in the GUI. And this statement, what do you think this statement's doing? You're setting, yeah, it's like you're setting a default value. It'll initially start at A. Same kind of thing that's done in this example down here. So in this case, the list would have old format, new format, and the default would be old format. So it's the same thing we've seen all semester, object.property, object.method. We have a double dot thing going on here because we've got self to start it, right? But self.object, this is the first parameter in the list. And altered, we said, is either true or false, right? So what is this statement doing, these two statements? Yeah. So it's the most frustrating GUI ever, which will, every time you change the value of the first parameter, it's going to pop up a message that says, no! Okay? Right? That's what it's going to do. If you change it, it gives you an error. Yeah. Okay, so, and here's an example similar to the one we had on the previous slide. What's the GUI output from this going to look like? Yes, a drop-down list with those two options for the second parameter. This one is just setting the value of the parameter, and if the parameter is enabled, it gives you an error message that says, whoopee! So the thing with working with the tool validator is code, you have to get to it from the script tool. So you have to open that script tool, right-click on Properties, get to that Validation tab, click Edit. It'll launch. By default, it launches Notepad. There you'll see the code that was appearing in here. You can't type in this box. It's like frozen inside of there. But if you click Edit, it'll launch something else. Then you have to edit your code over here, save it, close the Notepad. If you click Apply, you'll see the changes update inside of here. And if you click OK, then you can run it and see the changes work. If you have a problem in the code that you create, various things may go wrong when you run it, which maybe you'll see when you experiment with it. The thing is, Notepad doesn't have automatic indentation for you. It doesn't have syntax highlighting that you've gotten used to with Python Win. So you can set your script tool editor to something different, say like Python Win or PyScripter. And in the past, that is what I have recommended. However, yesterday, preparing for this class, I tried it out, and it was taking a really long time to launch Python Win when I did it that way. So it was a very frustrating process of any time I wanted to make a change, I had to wait for maybe 1 to 2 minutes for the thing to launch. So I went back to Notepad, but maybe that's an update that they screwed up when they did that. But anyway, so maybe that information is there. You can try it out. You follow these steps, change the path in here, browse to the thing, but it might be easier to stick with Notepad. So for the in-class exercise, I want you to get some practice making a GUI, and you'll see the instructions are you're to make a script tool that has 2 parameters. One, it has a label like favorite number, and the other one has a label of favorite color. The first one is a long data type, and the second one is a string data type. You're going to modify the update messages method inside the ToolValidator class so that it gives you an error if you put in a negative number. I'm going to show you an example of a version of this that doesn't have any changes to the ToolValidator. When you run it correctly, is going to just run and print some messages. The one that you make for class doesn't really have to have a script behind it. It can just be the front, the face of it, and it'll break when you try to run it. But if I put the number -5 in here, despite the fact that the directions say that it's supposed to be my favorite positive number, it's just happy to run. But if I want to restrict my user to a positive number, I need to do something in the ToolValidator. So that something in the ToolValidator would be something like the pseudocode here. If the first parameter has been altered, then if the first parameter's value is less than 0, set the error message to remind them that to use a positive number. Some hints down here. You'll need to use the parameters altered property and value property and the parameter set error message method. Okay, so your code should have ended up looking something like this, in which case you would, it looks a little different now, but if you click on the X, you get whatever error message you specified when you put it in there. So what kinds of problems did you experience before you got to the right solution? Of various, yeah. So I guess, like, make sure that when you have that open, you do edit, and then say OK or apply. If you say apply, then you can see your changes immediately in the window. Sure that when you want to check the value of a variable, you have to use that value property, because otherwise it's comparing it to, if you say if self.param0 less than or equal to 0, then you're comparing the parameter object to 0. You're not comparing the value of that parameter to 0. And apparently, true is always false. Here's another example where we're using, instead of the update messages, we're using the update parameter to enable or disable. So say you have a tool where it takes up to 3 parameters. The first parameter is the input feature. The second parameter is a tool that you want to use. Say you either want to get the count or you want to buffer the file. If you want to buffer the file, you want to get the user to give you a distance that you want to buffer by. If you don't want to buffer the file, you don't want to get that distance. You want to just get a count. You don't need that distance information. So this tool has update parameters information here that uses that enable property and sets it to true or false based on the selection in this box. So if you look at this code, let's see if you can tell me exactly how this works. So inside the update parameters method, we check, what's this line doing? Yes, if which parameter has been altered? the second one in the second box, right? If that parameter has been altered, then it does what? Yeah, so it checks to see if the person selected buffer. We've used a list of values over. Remember, you can set a filter to have so you can have a combo box, a drop-down box. Over in the parameters properties, you can give a list of values. If the value is equal to buffer, then what? Then we enable the third parameter. Okay, so it's available. Else, what? Yeah, it's disabled. We gray it out. Okay, that's the effect of this. It becomes grayed out. Here's another example that you could use to say, if the user selects a workspace, you can automatically get a list of rasters. If they select a workspace with the first parameter, you can do arcpy.list rasters inside of there and provide the user a list of rasters right there to select from. Here's the code. If there's anything in there, we are setting it equal to that list of names. Otherwise, we're using an empty list. So that's another example of using update parameters. That will have the effect, say if you select ncrast.mdb, it'll go through and list those, and it'll create the list down here for user to just check, check, check quickly. We said multi-value yes for this property. That'll allow the user to select multiple rasters. If you have that multi-value property set to no, it'll give you a drop-down, a combo box, so that they can only pick one. The thing about the tool validator is it is a bit touchy because you can't debug. It's hard to debug over there because you have to do it in a code editor that's just an editor. It doesn't have a debugger, and then you try it out, and if it breaks, then you have to open it up again, try to figure out what was wrong by hand, and so forth. So you can actually get more useful messages. You can write out exceptions and have them go into a file, right? See what we're doing on line 4? We're opening a file to report the errors to ourselves so that we can get that information in a written file and have it more convenient. So that's what this code is doing. Open the file, write out a named exception. You can just copy this code and close the file. And then you can open it up over here, and it says the integer division or modulo by 0 because we're dividing 1 by 0. Here's a full example with some debugging in it. Now try this in-class exercise to populate a parameter with the unique land cover values that you get by looking in a data set that is selected in another one of the parameters. There's some code out there on the in-class page which you can copy and make a script out of. Get that code working to get a list of unique values for a given field in a given GIS table, and then create a script tool. Set up 3 parameters. The tool doesn't actually need to point to code. The code that you created in part 1 will be used in the tool validator. It's not to be pointed to with the script tool. So you'll set up a dummy script tool, not pointing to any script. Set up 3 parameters. The instructions tell you which data type to use for each parameter and how to set up the obtained from. And then in step 3, you'll modify the tool validator class. You'll work on the update parameters method and modify that so that you have the third parameter set to a list of the values in the land cover types. So you're going to use the code that you created in step 1. You're going to modify that and put that into update parameters. Pause the video now and try this in-class exercise. Now let's take a look at a solution for this in-class exercise. In the first part, you created a script that would get a list of the unique values for a field in a given data set. The line 5 creates that search cursor, and then we create an empty list which we append to. On lines 7 through 9, we're looping through that data table, the records with the search cursor, and getting the value of the field name that we've specified, and that's cover. We've hard-coded it here, and we're appending that value to our list. And then line 12 casts the list to a set. A set can only contain unique values, so we've got that's how we compress it, so we don't have repeated occurrences of woods or orchards and so forth. Then we're going to need a list for our filter list, so we need to cast it back to a Python list. That's what happens on line 13. In the script, we print that value just to confirm that it looks like what we expect. Then we created our script tool with 3 parameters. The first parameter is set to park.shape. Then the second parameter can be selected as cover. And the second parameter was using the obtain from property and a field data type. The third parameter is the one that we're going to update in the tool validator. And that one was set to string. Finally, in step 3, we modified the tool validator class. We got inside that update parameters, and you can see the solution here with the line 20 altered is being checked. The second parameter, so we want to check if the second parameter is altered, because then we can know that it has a value in there that we can use to set our search cursor field name on. So we say self.params1.altered on line 20, and that's saying that'll return true or false. True if the second parameter has been altered. And then on line 21, we get that feature class name from the first parameter, and line 22 gets the value from the second parameter. That's getting the field name that was selected. Line 23 is creating that search cursor. So now we're using the code that we created up in the Python script on the left corner, number 1, and just kind of copying that code down into here. So the loop, the setting the value list with a loop is the same as we have in our script that we tested out in Python Win. And the reason we did that was so that we could get the bugs out of that part of it before trying it out in the tool validator. We delete our search cursor on line 29, and then on line 30 we cast the list to a set. So we're squashing it down to only the unique values. Before that we had a value in a list for each row in our table. On line 31 we cast it back to a list. So we're just taking that code from lines 12 and 13 up in our original script and sticking it in here. Now we want to use the list, the unique list, to set our filter list. That's what line 32 is doing. That is setting up the list that you see in the picture in number 2, in step number 2. Woods, other, and orchard is there because we have set parameter 2's filter list to the unique list. So you can imagine using, I hope you can imagine using this in a lot of different ways. You can dynamically populate the values of any parameter and use your Python code in the background to make that happen in a similar way. This video showed how the tool validator enables you to go beyond the internal validation. With the tool validator class, you can create custom warnings and errors and initialize and update parameters dynamically. In one example, we've restricted the user to only input positive numbers. You could use a similar technique to make sure a string doesn't contain any special characters, or to require a file name to contain a particular substring, or you could force the user to only select even numbers. We also use the ToolValidator to find the values of a field in a data set selected by the user in another input parameter. You could use a similar technique to find the range of numerical values in a selected field. You'd again use the search cursor to collect the values, and then you could use the built-in min and max functions to find the minimum and maximum values. Likewise, you could find the date span in a data set by using the search cursor with the date time module. These examples use search cursors, but standard file I/O could be used for a data set that is not yet GIS ready, so that you could provide a list of field names, since the obtained from property would not be able to do it, for example. With ideas like these, the ToolValidator class can create a more powerful, smarter, dynamic graphical user interface.